So let's start with today's topic. Today we are discussing a particle accelerator Van de Graaff generator. See, this is the topic of that chapter, last topic of the chapter. But the theory is in match with what we already discussed. So that's why I changed that order. Okay, so what is Van de Graaff generator? Van de Graaff generator is a particle accelerator. What do you mean by particle accelerator? Means which is used to increase the speed of charged particles like protons, electrons, etc. Such a device is called as particle accelerator. So to increase the speed, what it has to do, actually the speed is given by an acceleration, F is equal to what? ma, isn't it? So to give more acceleration, force is required. How comes this force? For charged particle, the force comes as per this equation, F is equal to QE. So in order to give that much force, you have to produce high electric field. Okay, you can say the same in terms of potential also, because to have more speed means it should have more energy, kinetic energy. To give that energy, how we can give that energy? V is U equal to QV, because this energy will get manifested as the kinetic energy. So you have to produce high potential. Okay, so in both the ways we can say, in order to accelerate a charged particle, you have to produce either high potential or high electric field you need to. So for such a case, what we use a device is called as Van de Graaff generator. Actually, the constructional details of Van de Graaff generator we need not study. Okay, it's given in the last page of that chapter. You need not study that. We need to study only that theory behind the working of Van de Graaff generator. So first we consider a charged spherical shell. The radius of the shell is capital letter R and the charge Q is given to the spherical shell. So it is a conducting shell. Because of that charge given capital letter Q will be distributed equally all over the surface. There will be uniform distribution of charge. Okay, so that total charge of the spherical shell is capital letter Q. Okay, and we have studied the field and potential produced by the spherical shell. The field due to the spherical shell outside the shell is as if the whole charge is concentrated at the center, isn't it? And inside the shell, the electric field is 0. And what about the potential? Potential outside, it varies as if the whole charge is at the center, and potential inside and on the surface are constant, isn't it? So on the surface, what is the potential? The same potential you have inside the shell. So inside the shell, field is 0, but potential is there, which is constant. Okay. So now we will assume another charged object, that is a charged sphere, small charged sphere whose radius is conducting sphere, whose radius is capital R. It is being introduced at the center of the spherical shell. So at the center of the spherical shell, a charged conducting sphere of radius R having a charge Q is introduced by method of insulating handle. Okay, so this is what we are considering. And what we find now is we have two conducting surfaces, that means charged surfaces, the surface of charged shell and the surface of the charged sphere. You know, the charged sphere is kept inside the shell where there is a potential. Now what we want to find is which is at a higher potential, whether the surface of the charged shell or the surface of this conducting sphere, which is at a higher potential. So to know that, first of all, we should write the expression for potential on the surface of spherical shell and the potential on the surface of conducting sphere. So potential on the surface of the spherical shell, see, the potential is produced by the spherical shell and also by the charged conducting sphere at the center. So due to the spherical shell, the potential on its surface is 1 by 4 pi epsilon 0 q by r. Okay. Now, what is the potential produced by this charged conducting sphere on the surface of spherical shell? That is 1 by 4 pi epsilon 0 q by capital letter R, because from the conducting sphere, the distance to the surface of the shell is capital letter R. But which charge is producing the potential? Small letter q. So these two terms, this is the contribution by the spherical shell itself, and this is the contribution by the charged sphere which is kept at the center. Okay. So by simplifying, we have 1 by 4 pi epsilon 0 into q by r plus q by r. So potential on the surface of a sphere, on the surface of the charged sphere, that is equal to the potential produced by the charged sphere and the potential due to the spherical shell. Since the charged sphere is kept inside the spherical shell, there is a potential due to this spherical shell. You know, inside the spherical shell, the potential is constant, and that potential is 1 by 4 pi epsilon 0 q by r. So on the surface of the sphere, that potential is there, plus the potential produced by its own charge. What is that? 1 by 4 pi epsilon 0 q by small letter r. So by combining, we have 1 by 4 pi epsilon 0 into q by r plus capital letter q by r. Now what we need to find is which is at higher potential, whether charged sphere or charged spherical shell, which surface is at higher potential. To find that, we need to find the difference in potential between the two. That means we'll just find VR minus VR. Okay. And determining whether it is positive or negative, we can conclude which is at a higher potential. So subtracting equation 1 from equation 2, we will have VR minus VR is equal to 1 by 4 pi epsilon 0 into, just write this term, okay, minus equation 1. So this is how. So when you expand and simplify, we will get the next term, next equation. So by expanding, we will have 1 by 4 pi epsilon 0 outside into within bracket q by r plus q by r minus q by r minus q by r because of this negative sign. So these two q by r, they get cancelled, and what we get is 1 by 4 pi epsilon 0 into q by r minus q by capital letter R. Okay, or you can take that q also outside, that is q by 4 pi epsilon 0 into 1 by r minus 1 by capital letter R. Now we have to see whether this term is positive or negative. Now you look at the small r and capital letter R. What about that magnitudes, the values 1 by r minus 1 by r? You know, the small r is less than capital letter R. So what about 1 by r? 1 by r will be greater than 1 by capital letter R. Got it? Because when we take the reciprocal, no, smaller the value, that 1 by r will be more. So if 1 by capital letter R is more than, 1 by small letter r is more than 1 by capital letter R, what about the term within bracket in this equation? That will be positive. This term will be positive. And we have considered positively charged shell and sphere. So this q also is positive. What does it mean? That is VR minus VR is a positive value. Okay. So for positive charge, this term will be positive. This term positive means what? VR is greater than VR. Means potential on the surface of the sphere is more than the potential on the surface of the spherical shell. It is something contradictory against our expectation. What we expect, because that small capital letter Q, it is evident from the diagram, capital letter Q is very much larger than small letter q. But what we are getting, potential on the surface of the sphere is more than the potential on the surface of the spherical shell. So the sphere is at a higher potential compared to this spherical shell. Okay, so we know the charge always it flows from higher potential to lower potential. That means if there is a potential difference, the charge can move, and under the action of that potential difference, in what direction it move is, for a positive charge it moves from higher potential to lower potential. If it is a negative charge, it will move from lower to higher potential. But here we have positively charged means positive charges, so it will be moving from higher potential to lower potential. So if we connect these two conducting surfaces, that means the sphere and the spherical shell, with the help of a connecting wire, what will happen? So this is at a higher potential, so here it is higher potential and here it is lower potential. So from higher potential the charge will flow to this lower potential. Got it? So the charge on this conducting spherical shell will go on increasing. Got it? So by keeping an arrangement like this, whatever be the charge on the spherical shell, okay, this inner sphere will be at a higher potential. So by having an arrangement like this, we can increase the charge on the spherical shell. So outside the spherical shell, the spherical shell will be producing a high field, because the field due to spherical shell is given by 1 by 4 pi epsilon 0 q by r, means any distance d I am taking d square. This is the potential, or not potential, field due to spherical shell. So as the charge q goes on increasing, the field produced by the spherical shell also increases. So if the high field is produced, that way we can accelerate the charged particle to a more value of kinetic energy or velocity. Okay, so that is the theory which we are using in Van de Graaff generator. By some means, we will have an inner sphere and an outer spherical shell, and both will be connected by a conducting wire, and continuously we will be supplying charge onto this conducting sphere. From that sphere, the charge will automatically flow to that surface of this spherical shell by this logic. Okay, always this conducting sphere will be at a higher potential and the charge flows to the spherical shell. Like that, a huge amount of charge get accumulated on the surface of spherical shell, and the field and hence the potential produced by the spherical shell outside the spherical shell will be very high. Using that field and potential, we can accelerate the charged particle. So for exam, there won't be any question like explain the working principle of Van de Graaff generator. Question they will ask in a twisted manner. That means by giving the arrangement as such, consider a spherical shell of radius capital letter R having a charge Q. Inside the spherical shell there is a connecting sphere, like that they will give, and they will ask which is at a higher potential. So whatever we discussed today, that's what you have to write. And they may ask a question like name a device which is used to produce high potential, like that. So Van de Graaff generator, that word you have to study. The experimental arrangement given in the textbook, it's not in the syllabus, it's removed from the syllabus. So only this much for today. Thank you.